Hi everyone, welcome back. In the previous two lectures, we introduced the production technology of the producer and discussed how to use production function to describe the production process of the producer. Any production process must involve inputs of various factors of production, which certainly incurs costs. And the costs directly affect the profit or loss of the producer, which in turn influence the producer's production decision. Therefore, in this lecture, we will examine the relationship between production costs and output, so as to understand the important role of costs in the decision-making of producer. To calculate how much a producer pays for production, we must first figure out which items should be included in the producer's cost. The cost we mentioned in daily life is usually an accounting concept. Accounting cost is the monetary expenditure that a producer must pay to obtain the right to use various factors of production, including interest rates, wages, rent, and the purchase of machinery, equipment, and raw materials, etc. Accounting cost is an actual payment, which is reflected in the accounting book. For example, you own a bookstore, and the annual operating cost is 5 million yuan. That is, the bookstore's accounting cost is 5 million. But you could also use the 5 million yuan in other ways. You could buy an apartment for investment. You could lend to others and charge interest rate. You could invest to open a coffee shop. When you use this 5 million yuan to run the bookstore, it means you give up the benefits of the other three uses. If the estimated revenue from investing in a coffee shop is the highest among these three options, which is estimated at 6 million per year, then the economic cost of opening a bookstore is to give up the revenue of coffee shop of 6 million yuan. From the bookstore example, we can see that economic cost measures the maximum value that input could receive in its best alternative use, also known as opportunity cost. This concept emphasizes the trade-off between different uses of scarce resources. Although opportunity cost is not actual monetary outflow, it directly affects producers' choice of how to use production factors. For example, continuing our bookstore case, if you invested 5 million to operate the bookstore, and at the end of the year, you got a revenue of 5.5 million. In the accounting book, you got a profit of 500,000 yuan. But are you willing to continue to operate the bookstore? This question can be answered more directly with economic profits. From the perspective of economics, the economic profit of operating a bookstore is equal to the revenue minus the opportunity cost. The opportunity cost of owning the bookstore is the foregone revenue from operating a coffee shop, 6 million yuan. That is to say, the economic profit should be 5.5 million minus 6 million, which is minus 0.5 million yuan. This means that in order to get the 5.5 million yuan revenue from the bookstore, you give up the 6 million income you might get from operating a coffee shop, and in effect, lost 500,000 yuan. Therefore, the business strategy is obvious. You should quit operating this bookstore. From this example, you can see that the concept of profit in economics is not the same as accounting profit. The profit we use in microeconomics is economic profit, which is revenue minus the opportunity cost. When we talk about the aim of producer is to maximize profit, we refer to the economic profits. If a producer obtains a positive economic profit, this means that the total revenue of the producer exceeds the opportunity cost, and the revenue obtained by the producer using its economic resources exceeds the potential maximum revenue of other uses, indicating that the manufacturing does not have any other better ways to use these economic resources. Conversely, if a producer faces a negative economic profit, it means that the producer has given up higher possible value for using these economic resources, and it should have used the resources in alternative ways. It can be seen that economic profit is a signal for resource allocation and reallocation. Positive economic profit is a signal of adding resources, and negative economic profit is a signal of withdrawing resources. Only when the economic profit is there, though, the producer has no incentive to adjust the use of their scarce resources. We know that the producer's profit is equal to total revenue minus total cost. We use P, W, and R to represent the price of output, the price of labor, and the price of capital. We use Y to represent the output level, and L and K to represent the quantity of labor and capital used. Assuming that the producer's production process uses only two factors of production, capital and labor, then its profit could be written as PY minus WL minus RK. To make profits, a producer first needs to organize labor and capital for production. To maximize profits, it must use the two factors of production most effectively. That is, to produce the product with the least cost. We can then split the solution of producer's profit maximization problem into two steps. First, we solve the cost minimization problem to find out the optimal use of factors of production, and then we solve the optimal output choice for profit maximizing producer. Today, we will discuss the first step, the cost minimization problem. In other words, we want to find out, in order to produce a certain output level, such as Y there though, how should the producer organize the factors of production at the minimum cost? We first use graph to find the answer. We use the horizontal axis to represent the quantity of labor, and the vertical axis to represent the quantity of capital used in the production process. Then each point in this coordinate represents an input bundle. Given an output level Y there though, we can draw an isoquant curve. Each point on this curve shows the input bundle that could produce Y there though amount of output. But which point could produce Y there though with the least cost? Let's take a step back. We denote the total cost equal to a certain value Ci, where Ci is a constant number. Then, by definition, all input bundles that satisfy WL plus RK equal to Ci must consume the same cost. If we collect these input bundles, we get an isocost line, where iso means equal, as in the word of isoquant. If we rearrange the equation of total cost, we have K equal to Ci divided by R minus WL divided by R. Given that factor prices W and R are also fixed, we can see that the isocost line is a straight line. Its intercept is Ci divided by R, and its slope is negative W divided by R. Actually, we can draw an isocost line for any number of Ci. So eventually, the isocost line for a producer is a series of parallel straight lines that is downward sloping, where the isocost line further away in the northeast direction represent higher cost level. The producer's goal is to produce wider quantity of outputs with the lowest cost. As can be seen from the graph, when the isoquant curve is tangent to the isocost line, the input bundle has the minimum cost to produce wider. Any input bundle lower than this cost level cannot produce wider output, and any input bundle higher than this cost level is not economical. So to summarize, when production cost is minimized, the slope of the isoquant curve must be equal to the isocost line. This means the condition for cost minimization problem is the ratio of the factor price W over R is equal to the technical rate of substitution of L for K. Next, we derive the mathematical solution to this cost minimization problem. First, we set up the Lagrange function giving our objective function and constraint. The choice variable in this function is L and K. Then, taking the first-order partial derivatives of the input quantities of the two factors and the Lagrange multiplier lambda, we obtain three equations from the first-order condition. The answer to the first two equations produce the same result as we solved using graph. It shows that the solution for the optimal input bundle should be the relative price of the factors is equal to the ratio of their marginal product. A bit of transformation of this formula helps us understand its economic meaning. The left side of this equation represents the marginal product per unit of money spent on capital, and the right side of the equation represents the marginal product per unit of money spent on labor. It shows that in order to minimize cost, the marginal product generated by the last unit of money spent on all factors should be equal. If MPK divided by R is greater than MPL divided by W, then the same unit of money spent on capital will bring more output than labor. If the producer reduces labor input and increases capital input, she can produce the same number of output at a lower cost. Conversely, if MPK divided by R is less than MPL divided by W, reducing capital and increasing labor could save cost. By solving the above cost minimization problem, we can find out the optimal combination of factor inputs to produce wider output. It is not difficult to find an optimal combination of factor inputs for any output level. So there is a one-to-one correspondence between output level and input bundle. The optimal input quantity of factors or the demand quantities of factor depends on how much output the producer wants to produce. It can be seen that cost minimization leads to a demand for labor and capital that is contingent on the level of output being produced. It is also called a derived demand, since it is based on the firm's output. Given different output level, we can find a series of optimal factor input bundles. If we collect all of these input bundles, we find a trajectory of the producer's production change. This line reflects how the optimal input amount of factors varies with the output change. We call it expansion path. It is the collection of cost minimization tendencies at every level of output. We just mentioned that the demand for inputs is derived from the output level. That is to say, the demand for inputs with minimum cost is a function of the output level Y. Since the total cost is equal to the factor price multiplied by the factor demand and then summing up, it must be a function of factor price and output level. Solving the cost minimization problem allows us to find out the minimum total cost that producer need to pay to produce any output level at any given input prices. We call it the total cost function. Alright, today we introduce the definition of cost in economics, that is opportunity cost, and then we graphically and mathematically solve the cost minimization problem of the producer and find out the derived demand function, expansion path, and total cost function based on that. In the next lecture, we will further distinguish between short-run and long-run cost and discuss cost in more details. Hope to see you soon.